Our final example, we're going to take a 75 Newton force and pull a crate horizontally across the floor. It's going to set up pretty similar to example 2. So here's my crate moving across the floor again horizontally, so there's no incline. Has a force of friction of 20 newtons acting on it. Force of friction 20.0 newtons. Crate accelerates, so we have an acceleration, so it means it's going to be moving opposing the force of friction, so the acceleration will be 1.50 meters per second squared. We know that there's a 75 Newton force applied on the object. 75.0 newtons applied. We want to know what the weight, this question's asking for Fg on this crate. So it's actually quite similar to example 2. Example 2, I think, had us find the acceleration given the mass. Well, now you're going to use the acceleration to find the mass. Then once you know the mass, you'll find Fg. So again, what our goal here is to find Fg. Well, to find the weight of an object, we need to know the mass and we need to know gravity. Well, we don't know the mass yet, but we can find the mass using the F-net formula. We know that on the second equation here, acceleration equals F-net over m. So if we find m, equation 2, mass will be equal to F-net divided by acceleration. Well, again, looking at our diagram, the net force that's going to cause this thing, and it's accelerating horizontally. So you might be thinking to yourself, well, doesn't the force due to gravity affect its acceleration? Well, remember, the acceleration is horizontally, so we care about the forces horizontally. Well, the only forces acting horizontally are the applied and the force of friction. This object isn't falling, which would worry about gravity. This object isn't rising, which would worry about the force due to gravity. This object is moving horizontally. That's a very key word in this question, because if it was moving upward or downward, we would care about its force due to gravity and the applied force in an upward direction. So to find the net force in this case, again, what we're going to do is subtract the applied force minus the force of friction and divide it by the acceleration. That's how we find mass. Now, again, I have two formulas. I can go and find the mass by punching those numbers in, or what I could do is do one single substitution and write this as force due to gravity equals mass Fa minus Ff. Don't forget to multiply that whole thing by g, and we're going to divide it by a. Don't cancel a and g. This object is accelerating horizontally at 1.50 meters per second squared. Acceleration due to gravity is downward. So don't mix up those two numbers. G is 9.81. Acceleration is 1.50. So if we put these numbers in, and again, if you want to do it in two steps, you will get the right answer. I just like to do one single calculation. So it's going to be 75.0 newtons minus 20.0 newtons. I'm going to multiply that number by 9.81 newtons per kilogram. And I'm going to divide that by 1.50. And I'm going to use newtons per kilogram for acceleration in here as well, so that if you are kind of looking at your units when you do this, you can see that the newtons per kilogram divide out with newtons per kilogram, and that when you just left with the units of newtons at the end, which should be appropriate because you are dealing with a force due to gravity. So again, the way you punch this in, 75 subtract 20, which gives you basically 55, times 9.81. Divide that answer by 1.5, and you should get 359.7. And again, if we go to the appropriate significant digits, should round to 360 newtons. Just remember, net force means the addition or the resultant force, so you may have to add or subtract if you have multiple forces acting on the object. The key to dealing with these is that diagram and labeling the forces on the diagram. Once you have that, then it just becomes a number problem and a substitution into a formula.